Welcome back. As you know, I am Eli the Computer Guy, and in today's class, we're going to be doing a nifty, neat little project to show you how values can be transferred between devices and between different programming languages. So basically, in today's class, we are going to have the same basic setup we've had in numerous other classes, where we are going to have our Arduino connected to our Raspberry Pi using a USB cable, and they are going to be communicating using the serial connection. I am then going to be connecting an analog temperature sensor to the Arduino. The Arduino is going to read the value that is coming in from that temperature sensor and is going to turn that into a degrees Fahrenheit. From there, it will then send that information to the Raspberry Pi. The Raspberry Pi will use Python in order to read the value coming in through that serial connection. From that point, what is going to happen is that value is then going to be saved into a file, where a PHP script is then going to pick up that value, and it's actually going to be able to dynamically create a web page based off of whatever that value is. So on the Raspberry Pi, we will install Apache and we will install PHP, and then PHP will be able to look into that file where we're storing the value that we got from the Arduino. It will be able to grab the number, then based off of whatever number that is, it then will determine whether the color that should be presented on a web page should be red, green, or blue. So basically, is the temperature too hot? Is the temperature just right? Or is it cold? And then out on a web page, it will dynamically be able to write what the temperature is, and that web page will refresh every 5 seconds. So the important thing to understand with this particular project today is the real world utility of this project is probably pretty nil, right? Even if I was going to do a project like this where I wanted the same end results, I would probably just connect the analog temperature sensor directly to the Raspberry Pi and skip the Arduino. The important thing I want you to understand today is basically how we are transitioning these values from an Arduino to the Raspberry Pi, how we're able to use that value in a Python script, and then how we're able to save that value so a PHP script can pick it up, and then how that PHP script can then do something dynamically based off of whatever that value is. Today's class, again, is not necessarily very useful in the real world, but the understanding of how you can basically take those values, send those values, store those values, read those values from other scripts, I think that type of thing is very valuable. So that's what we're going to be doing in the class today. So for the warnings today, there's 2 hiccups that might cause you a problem when you actually go to run this project. One, make sure that you actually run the Python script, right? So you install Apache, you have PHP, you have the Arduino, but if the Python script itself is not running, then basically when the Arduino is sending the communication to the Raspberry Pi, nothing will happen past that, and everything else doesn't really matter. Also, on top of that, do remember with the Python script, we are going to be writing to a file. So in the class, when we actually go to the Raspberry Pi, I'll show you how to do this, but make sure you change the HTML directory so that the owner of that directory is going to be Pi, the default user for your Raspberry Pi, so that you're actually able to write to the file. So if you create a file, but basically, whoever is trying to write to it doesn't have permission to write to the file, then everything will fail out. So the big concerns for today is just make sure you hit that run button, that you're actually running the Python script, and then also just make sure that the permissions are correct so that you can actually write to the file from the Python script. With that, basically, you would just change own to pi for /var/www/html. Past that, we're actually dealing with a lot of different subjects at a very low level. So you're going to have to understand how the Arduino works, how the Arduino IDE works, and how to be able to code in order to make the temperature sensor work. You're going to need to know the basics about Python, so you can actually write the basic Python script. Beyond that, we're then going to install Apache. So when we install Apache, we are not doing anything additional. We're just installing default Apache, so you don't have to worry about any configurations there. We are then going to be installing just the default PHP, so we're not going to install any other modules or anything else. We're just going to be installing PHP. We are then going to be using PHP to write the dynamic web page, and so you're going to have to understand a basic bit of PHP. PHP, and when it's writing that dynamic web page, it's going to be writing out in HTML, obviously, and also CSS, so you should have a decent little understanding of CSS. Nothing that we're doing is very high level today. This is all incredibly like introduction across the board, but this is where I say, like in the technology world, you take a lot of introductory classes or a lot of introductory concepts, you kind of glue them all together into a project that becomes much more complicated. So basically, if you get confused with anything, do make sure to go take a look at the code examples, and that should be the only problems that you might have. So with that, let's go over to the workbench. I can show you how this project looks once we're finished. Then I will show you the physical build of this project, and then we'll go through. I'll show you the Arduino code, and then I'll show you the Raspberry Pi code and what you need to do to set up the Raspberry Pi. So here we are. This is what the project looks like once we've completed it. So we have our Arduino Uno like we normally do, and that is connected to our standard analog temperature sensor. Beyond that, we have the USB cable. This is then connected to the Raspberry Pi. And so then on the Raspberry Pi, we've installed Apache and we've installed PHP. And so that allows us to present a website to any client computers that come to the server. So this is now also a web server. So if we go here, basically, I'm on my demonstration computer, and so on the demonstration computer, I've gone to 192.168.1.4. That is the IP address of this Raspberry Pi, and I have this Temp App Php script sitting in the var www HTML folder so that we can take a look at it. When we're actually taking a look at this web page, basically I'm just printing out a title at the top to say what this particular project is, and then right here, this is what we're showing for what the temperature is. So every 5 seconds, this page will auto refresh. Basically, the idea being is if the temperature is above 70 degrees, the font will be red. If the temperature is between 70 to 60 degrees, it will be green. And if it is below 60 degrees, it will be blue as it is. So if I go over here and I simply put my finger on the temperature sensor, after 5 seconds, this basically refreshes, and now we can see it goes up to 70.32 degrees and it's red. Then after that, it goes down to 67 degrees and it's green. And so this is just a basic example here of how that PHP is able to take the number and then basically be able to do an if-else statement based off of that number in order to create this dynamic web page. So with that, I will show you the actual physical build for this project. Then I'll show you the Arduino code and then the Raspberry Pi code and setup. So this is the physical build for this particular project. There's not a lot to it. It's the same standard thing I do for so many of these Arduino projects where we're simply using the analog temperature sensor as a way of getting a dynamic input to the Arduino. So we simply have our standard Arduino Uno here, though any Arduino board will work for this. This is connected to the analog temperature sensor. This goes to basically the output for the analog temperature sensor goes to A0, and then past that, I'm simply using a USB cable to connect to the Raspberry Pi, and that's all there is to it. So let's go over and take a look at the Arduino code. So here is the Arduino sketch for you. You will notice it's very simple. It's only about 16 lines of code. And the reason is all we are going to be doing is we're going to be sending out the value for the temperature Fahrenheit using the serial.println command so that it can be picked up by the Raspberry Pi. And that's it. The Raspberry Pi will not be sending any commands back, will not be sending any information back. So all we need to do here is we simply need to be able to configure the temperature sensor, start the serial monitor, and then be able to get what the temperature value is and be able to print that out. So if we go up here, all we're going to be doing is we're simply going to define the sensor pin to be pin A0. So the analog temperature sensor will connect to digital or analog pin A0 on the board, and that's it. Past that, we're then going to go here to serial.begin, and we're then going to begin the serial speed at 9600. The most important thing here is that this speed is the same as what you have in your Python script. The default standard, I would just leave it at 9600, but that's what we're going to be doing here. That's all there is for the setup. Then we're going to go into the loop. The loop is something you should recognize a lot at this point. Again, just a copy paste thing. What we're going to be doing here is we're going to be taking the value coming in from the analog sensor, and then we're going to be turning it into a value for temperature Fahrenheit. Then we are simply going to be doing serial.println whatever that value is. So that's going to get printed out, and that is going to be able to get grabbed by the Raspberry Pi for processing discussing. I'm simply going to delay this for 1 second here, just so it's not looping as fast as it can. You could theoretically delay it longer or delay it less, depending on how accurate, how up to date you want the value to be. For a project like this, 1 second or maybe even 5 seconds or 10 seconds is probably okay. But I'm just putting this at 1 second. So this is what the sketch looks like. So let's go over and take a look at the Raspberry Pi Python code. Okay, so here we are at my Raspberry Pi, and again, this is a pretty stock standard Raspberry Pi. The only additional things that I have done at this point is I've installed Apache 2, I've installed PHP, and I changed the ownership of the HTML directory under var www to Pi. So let me just show you how to do that real quick. So the first thing is you do need to install a web server in order to be able to present a website to a client. Again, I'm going to be showing you how to do it with Apache 2 because, as they say, I'm a boomer. So you do sudo apt-get install, and then you're going to do Apache 2. So Apache 2 here, this is, the old go-to for a web server, and so that is what I will be installing. Then the next thing after that, so basically with this, I would just hit enter and go through and actually install it. Since I've already installed it, I won't do that. The next thing that I need to do is then do sudo apt-get install PHP. So this will install the PHP scripting language so that that web server software can go in and actually interpret a PHP script in order to be able to build that dynamic web page, and so I will simply install that. Again, I'm not installing any additional modules or anything else. That is all I'm going to be installing. Now, once I have installed Apache 2, one of the things we are going to get is we are going to get a new folder, right? So basically, if you go, basically here in the folder structure, what you're going to do is you're going to go to var www, and then you're going to get this HTML folder. So when you install Apache 2, it will add the www folder and it will install the HTML folder. The HTML folder, this is where all of your public web pages will be. So basically any scripts, any pages you want to be able to access from an external web browser, this is where everything has to get dumped. The thing is, when you initially install Apache 2, Pi is not the owner of this particular folder. Why that's important is because then Pi is not allowed to write into the folder. So HTML by default is readable by everybody, is not writable by everybody. So if you create your Python script that you're going to be running under yourself under the username of Pi, and you don't give yourself ownership, or if you don't change the permissions at least, basically the Python script will not be able to write into that HTML folder. So in order to fix that, what we're then going to do is we're simply going to go sudo chown Pi. So Pi is the default username for the user account on the Raspberry Pi. Now, if you're using a different user account, use that different user account. I'm using Pi because I'm just using the default here, right? And then you're going to do /var /www /HTML. And what this is going to do is it's going to change the ownership of that HTML folder so that Pi owns it, so that when you run the Python script, you will actually have permissions to be able to write into that folder and create your data.txt file. So these are the first things that you need to do a setup, again, beyond the initial Raspberry Pi setup. Beyond that, again, this is the stock standard. I simply installed the Raspberry Pi OS using the Raspberry Pi imager, and so these are the only additional things. So past that, let's now go and actually take a look at the Python script. So when we're looking at the scripts today, we're going to have a Python script. In the Python script, we're going to be dealing with an Athani, and then we're going to be dealing with the PHP script, and we're going to be dealing with that in the other IDE that is on Raspberry Pi called Genie. Just so you understand what's going on there. So this is what we're going to be doing, and it looks pretty similar to what we've done in the previous projects, right? There's only about 14 lines of code here, and frankly, it could be shorter if I wanted it to be. So the first thing that we're going to be doing is importing the serial module so that we can actually have serial communication with the Python script. We're going to import serial. We're then going to do this if name equals main, that normal thing, and then we're going to do the serial, SER, so we create the variable for serial, serial dot uppercase S, the rest Arial, lowercase. We're going to connect at /dev /tty acm1. So that is currently where my Oh, my Raspberry Pi is connected. Again, this may iterate up or down on you depending on when you're plugging and unplugging your Arduino into the Raspberry Pi. So it may be either ACM1 or ACM0. If the script fails, just change this, and that's probably the problem there. Then we put the baud speed, 9600. Again, that has to be the same as what is on your Arduino. And then we do a timeout in seconds, so 1 second. So if there's not a communication or if everything locks up, just timeout, reset after 1 second. This keeps your entire system from freezing up because of some weird glitch. Then we're going to simply flush out the buffer here. Again, this is the stock standard stuff we've been doing with all of these serial projects. Then we're going to come down here and we're going to say while true. So basically this is going to be a loop and it's always going to be true. So therefore, it's always going to continuously loop, 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 loop. If SER, that serial connection in waiting, is greater than 0, so basically if there's some kind of serial communication, then what I want to do is we're going to have a variable called line. It is going to equal the serial read line. So this is a function that reads the line coming in from the serial communication, decodes the UTF-8. So basically what this does is this actually decodes what's coming in into text, into a normal readable format that we can deal with. And then our strip is going to strip out any extraneous white spaces. This can be very important. Again, right now, basically what we're going to be doing is we are going to be sending floats. So floats are variables with decimal points. And so if you're testing against an int or a float or any kind of number, and then you have weird extra white spaces around that number, you can run into nasty problems when you get to the conditionals of, you know, if the number equals X, then do something else, right? Because you can run into a problem where basically since you have that additional white space, nothing ever equals what it's supposed to equal, and you get into a mess. So that's why we do strip out the white space here. The next thing we're going to do is we're going to create a variable called file, and what we're going to do with that is we're going to have a function, and this function is going to open or create, so this will create the file if it doesn't already exist. And we're going to say in var www html, we are going to create a file called data.txt. Now it is important, again, we're dealing with the Linux world, the web world. The extension here doesn't really matter. You could do data.dat. So this is actually what you see in a lot of applications. Essentially, they have text files. They just end it with a .dat extension so that you don't mess around with it. We're going to leave it as a .txt just to make it easier on you. But you can name this essentially whatever you want. You know, something, you know, temp.dat or something like that. Then we're going to do the comma here, and then we are going to do a write. So with the W, with this particular option right here, this particular argument, what this is going to do is it's going to overwrite the file. Very important. If you put an A, that will append the file. What we want to do is overwrite the file. So what's going to happen is the value for the temperature is going to come from the Arduino. That value is going to be processed by this Python script, and that value is going to be dumped into the text file. The next time a value comes in from the Arduino, that the first value will be overwritten, and the new value will be put in, and then it will be overwritten, and then it will be overwritten, and then it will be overwritten. What we're simply doing with this data.txt file is we're just simply using this as a very, 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 very simple data store to allow us to store a variable value so that we can pass it off to a different type of programming language. So we're just going to be doing W here. If you did like A instead, you probably get a whole bunch of mess, because basically that would then append. It would keep adding additional numbers to this data.txt file, and then again you're just going to get a mess out of that. So we're going to do write. Then what we're going to do here is we're going to do file, write, and then line. So basically with file, all right, that's opening this particular file. And so then what we're going to do now is that particular file we are going to write to, and we're going to write the value of line to it. Past that, we're simply going to do file.close. So this is a function that closes the file. Do make sure that you close the file. And then for troubleshooting purposes, we're going to do print the value of line, and that is going to print down here so that we can verify that values are actually getting passed properly. Past that, we can then go over to the HTML folder. In the HTML folder, we can see we have this data.txt file. If I double click on the data.txt file, we can see the last temperature that this particular system read before I turned it off. And so the last value it read was 69.44, right? So basically, as we have the Python script running, this will get overwritten. Every time a new number comes in, the old one will get overwritten, the new one will get put here, and that's how that is. So then past that, we are then going to have the Temp App.php. So this is going to be the script, the PHP script that's actually going to process the value coming in and turn that into that dynamic web page. If we open that up, this is what it looks like. And it's a pretty simple PHP script if you take a look at it, with some if else statements and a little bit of CSS, a little dynamic CSS to make this interesting. So the first thing that we're going to do up here is, this is one of my little duct tape things I do for kind of like these dynamic projects. A lot of old timers complain you could do this better in JavaScript, you could do this better with probably different programming languages, but this is HTML. It works really well. And so again, if you don't need to do anything too complicated, you basically just need an auto-updating web page. This is the best. I think this is one of the best ways to do it. And so what this is, and so you'll notice the PHP script starts down here. So this isn't print. I'm simply writing out the HTML code on this particular page, and it's before the PHP script. So what we're doing here is this allows the web page, or basically it sets the web page to auto refresh itself every 5 seconds. So meta for metadata, http-equiv equals refresh. So what we want to do is refresh the content every 5 seconds. So this will dynamically, basically, it will reload the web page every 5 seconds. When it reloads the web page, then it will pull the new value from the data.txt, process that, and do everything else. Again, do realize this is outside the PHP script. We're then going to open up the PHP script. First thing that we're going to do is we do need that value for the temperature variable. So we're going to create a variable, $temp. So that's, again, how you create a variable in PHP. Do remember to make sure you have that $, that's important. Then we're going to use the function file_get contents, and we're going to go to that data.txt file. Since the PHP script is in the same directory as the data.txt file, I don't have to put a full folder structure there. So basically, we're just going to get the contents of data.txt, and the value of that is now going to be the value for temp. And so that's why it's important you don't append, right? So when you overwrite, you're only going to get 69.44 or 80.21, right? You know what you're going to get. If you did append, you will get 69.41, 80.55, 55.66, right? It would append all of that, and then all of that would get turned into a value for temp. So that's why you have to make sure you do that right, that overwrite in the Python script. Then we're going to come down here, pretty simple. So what we're going to say is if $temp is greater or equal to 70, then what we're going to do is we're going to change the value of a variable color to red. So this is the variable that we're going to use for the CSS, for the color for the CSS. Else if temp is greater or equal to 60 and temp is greater than 70, we're going to change the color to green. Else if temp is less than 60, color is going to equal blue. Else, so I just put an additional else in case I do something stupid, in case it's just the number doesn't make any sense. Again, like if I appended and so it's a really crappy number, or a string comes through, you can get all kinds of weird problems with code. And so I'm just putting that additional little else in so we can do color equals black. So if I'm getting a weird output, then it's formatted as black, and I can go, okay, that's not a color I'm supposed to be seeing. Let's see what the issue is. Okay, past that, we're then going to go down here, and within PHP, so again, this up here is outside of PHP, so I do not need the print. This is inside PHP, so I do need the print. Theoretically, I guess you could put this outside PHP, but I like keeping everything kind of together logically. Like when I'm doing my code, I like to keep everything logically within blocks, and so that's why I'm printing out here. You do you. Print, and then we're going to do h1 style, text align center, and the Arduino Raspberry Pi temp web device. So basically what that looks like is if we go here to the actual web page, this is what we're looking at right there. So then we go back and we do a break. So we give us an additional little line, a break, and then we do print. And this is where we are going to dynamically format and print out the temperature, right? So basically what we're going to do here is p style. So for CSS, text align equals center. Font size equals 200 pixels. Margin top and margin bottom equals 10 pixels. So with CSS, it's useful to go in and modify the margins here. So I put this pretty small to 10 pixels because basically, if you take a look at the web page, right, you generally get a margin about the size of whatever text you're writing. So if I have a 200 pixel size for the font, I'll get 200 pixels of white space below it and 200 pixels of white space above it. So basically, this number right here, if I don't modify the margin, will show up somewhere down here, a lot lower on the page. So I don't like that. So I'm simply modifying the margin so that it shows a little bit closer to where the title is. So one of those things. Again, you just go in there, you tweak, you adjust. Then we come down here to color. Right, so past the margin hyphen bottom, that's for 10 pixels. Then we do color colon, and then we're going to concatenate in that color value. So whatever value we've determined from these if else statements, that is the value that's going to get printed out here. So the color, we close the double quotation mark. We then do a period for the concatenation. We do $sign color, so the value for color, green, blue, red, or black, will come here. We then concatenate back in to the string that we're printing, and so we do another period at the end, and then we do the double quotation marks. So basically, all of this has to be wrapped within the double quotation marks, and the variable value has to be wrapped within the periods too. Then we're going to close the semicolon, and then we're going to close the CSS. This is where it can get very, very confusing very quickly when you're building dynamic web pages, because you have so many things opening, so many things closing, so much different stuff going on. It's very easy to forget one of these things, right? Because you have to, whenever you give a value for something in CSS, you have to close that with a semicolon. Whenever you concatenate in, you have to contain that within the double quotation marks and the periods. When you're going to be closing the CSS, then you're going to have to close with a single quotation mark. And so this can get complicated. So if you're running into any problems, I would bet 90% you screwed up something in this little typing right here. Then we're going to go and we're going to close out the opening p tag there, and then we're going to concatenate in what the temperature is. So double quotation marks. So we're coming out of this print string again. We're doing period, whatever the value for temp is, then period, and then the double quotation marks. So we can come back in, close the p tag, and then we're going to close this print statement, and then we're going to go close the semicolon so that PHP knows to process all of this. And this is basically what the script looks like. So what we have here is the Python script is then going to be sending the value to the data.txt file. Then you're going to have the PHP script. It is going to be opening that file, doing an if else statement based off of what is in there, and then it will be dynamically creating our web page for us. And this is how it works. So one of the troubleshooting things that we can do to make sure everything is working properly is if we go here, what I can show you is, since I'm going to be printing out, since I actually print out a line in the shell, when I hit the run script, one of the things I can do is I can verify that it's actually printing out a value here, and that it's actually dynamic. Because sometimes I may get something screwed up, like with the Arduino or whatever else, and so I can touch the temperature sensor here. I can then see the value is going up approximately how it should, so that's looking good. And then I can go over here, and I can take a look at the actual dynamic web page itself. Again, it refreshes every 5 seconds, so I can see that that's looking good. And then what I can do, again, like I say, from that troubleshooting perspective, I can just simply go back and forth and try to determine what the problem is, right? If I go back, let's say, to the Raspberry Pi, one of the things I can do is I can look at the data.txt file. And so let's say if I stop this and it's at 7032, I can go to the data.txt file and I can see what's in there. And so it's 732, right? So this way, I can see that the Python script is able to get the variable value from the Arduino, and it's able to print out here. I then can go to the data.txt and I can verify that it's actually writing appropriately to that data.txt file. And then I can go and I can take a look at the web page itself and make sure that it's showing up there how it's supposed to. So like with this right now, like this is all locked up, right? See, so it got to 7032.32 and now it's not refreshing. So it's like I can sit here and I can go, well, wait a minute. So it's 7:32, but it's not refreshing at all. It's not changing. Okay, let me go and let me see what's going on. And then I can see, oh, wait a minute. I turned off. I stopped my Python script. Maybe that's a problem. Let's see if I start my Python script again. Okay, now that's actually processing new stuff. And then if I go over to my web page, okay, now the web page is actually changing like it's supposed to. So again, a very important thing with all these kind of coding projects is actually building in troubleshooting routines, especially when you're new and you're not really sure how this crap is supposed to work to begin with. By adding those troubleshooting routines, it'll make your life a lot easier for fixing problems. So that's basically how this project works. So there you go. Now you understand how to make more complicated systems. So with this, we have the Arduino. The Arduino is getting a value from the temperature sensor, sending that value to the Raspberry Pi. Raspberry Pi is processing that value in Python, saving that value into a file. PHP is then picking up that value and dynamically printing out a web page. Again, for any of the 20-year experienced veteran programmers out there, yeah, there's a lot better ways to do this particular project. What I want you to start understanding, though, is how you can connect these devices, how you can connect these different programming languages, basically to hand off tasks from different subsystems, different systems, basically hand off tasks from one programming language to another so that you can build more complicated things. This may also start to give you an idea of what it means when people start talking about being front-end developers or back-end developers and how that works in projects. Imagine if you made this project a hell of a lot more complicated. Here, what you could do is you could have one person simply working on the sensor array for the Arduino and making sure that the Arduino is sending out the proper values to the Raspberry Pi, right? So you could have one engineer that sits down and they spend a day, a week, a month, a year designing a sensor array and making sure that the values that it's sending are what, you know, the Raspberry Pi engineer would need in order to do something. And then you could have the person that's responsible for the Raspberry Pi, or essentially somebody who's responsible for the compute. And what you can do is you can have them, they can create the Python script. They can install Apache, they can install the PHP, they can be responsible for that component and basically of taking the values coming in from the Arduino and then what to do with them past then. Does it take those values and put them into a database? Does it take those values and send something off to an API? Does it take those values and simply write it into a text file, right? You can have one engineer, you can have one technical professional, and that's what they're focused on. Then you can have another technical professional on what to do with the data past that. Once you've actually been able to store the data into some kind of data store that people can interact with, that's where you could have somebody else, and they then will go and configure their own dashboards, their own system. So imagine, let's say you have a company like with inventory control systems, or again like HVAC or environmental sensor systems. Basically, you can have the first two engineers create the system to dump the data into a database or into a file or something like that, and then you can have a different engineer or multiple different engineers all then be able to grab that data from that single data store and then be able to make some kind of visualization that they find valuable. Then beyond that, again, I showed you with the HTML and the CSS, I showed you very basic formatting, but in a larger project, you would have a front-end developer, and the front-end developer, the UI, UX person, would be responsible for making sure everything is pretty, making sure all the fonts are perfect, making sure the background is perfect, making sure all of the margins, should it be a 10 pixel margin or a 15 pixel margin or a 11 and a, I don't know, can you do 11 and a half? I don't know, like 11 pixel margin, right? They can make sure all of that is together. And so with this particular project, it shows you how you can start compartmentalizing different components of projects. And so you can build something really cool, or you can compartmentalize it in such a way that you can start handing off tasks to other people. Okay, you're going to create the Arduino sensor array, and from the Arduino sensor array, this is what the data output looks like. All we care from you is that the data output is correct and that it's formatted in this fashion. Then I can go to the next engineer. It's like, okay, you are going to be getting data formatted in this fashion. And so what we need you to do is we need you to process that data and then put it into a data store or something else. And then we go to the next person. We say, okay, once that data is in a data store, we need you to be able to create visualizations, dashboards, whatever else, to be able to make that useful to the end user. And then you go to the final person, you go, okay, you have all this in front of you, now make it look pretty. Right? That's how these large projects look at the end of the day. We're just using something very simple here to explain that concept. So go play with this, see what you can do. Again, if you know anything about databases, you can dump the information into databases. If you know anything about APIs, you can do something with an API. Go play with this, see what you can do. The main thing here is just, again, understanding how things are handed off so that you can create these bigger systems. So as always, I enjoyed teaching in this class. I look forward to seeing you in the next one.